Hey, good morning or afternoon, you lucky people, you. Because we seems to have some time off from school, but you know me, we're not going to let that learning lack, all right? So we're going to get back into that instruction. Here's some instructional videos. Normally instruction happens in the classroom. Well, guess what? Now the classroom is our Google Classroom. It's virtual learning time, people. We got this. You're going to do awesome. Same as usual. Go to that Google Classroom, geometry. Find this classwork. The classwork we're going to do today. Sorry, had a little technical glitch there. We're going to do angle pairs. So go on to Geometry Unit 1. Geometry Unit 1. Look for Geometry Unit 1, 1.5, Lesson 5, angle pairs. All right. This is going to be due, I think, by Wednesday or Thursday. We'll see how it goes. I'm going to provide you the instruction, and you're going to complete this. So this is what it looks like when you pop open this Google form. And we've got two learning targets today. Two learning targets. The first learning target is I can identify adjacent, vertical, complementary, and supplementary angles. I can find measures of angles. I can find the measures of pairs of angles. All right. And let's see. So that's exactly what we want you to do. So put your name on here and put the learning target over here. So again, you can cut and paste. You can cut and paste your learning targets. However, if you wanted to write them out, that'd be fine too. Purpose of this is so that we understand each other, and that I know that you have at least seen and looked at and at least copied and pasted the learning target and heard it once, right? So vocabulary. Adjacent angles. I feel like I'm going to need a diagram to just have you understand adjacent angles. So let me get. Oh, that's not the diagram I was looking for. Let me draw a line here, and let me say I got a line here, and oops, sorry, technical glitch. All right, we got that glitch figured out there. All right, adjacent angles. Well, if I call this angle here angle 1, then I call this angle here angle 2. Well, these two angles are what's known as adjacent. They're next to each other. They share a side. All right, they share a side. I could also have a situation where I've got, something that looks like this, and then, this could be angle 3, and this could be angle 4. Don't mind the hash marks there. All these little marks, they're just saying that this is a measure, and I put 3 in there, or 4 in there, and I put 3 in this one. Since I named this angle 3 and angle 4, I kind of wish I would have done that in reverse, but it doesn't actually matter. These two are adjacent angles, right? 3 is adjacent to 4. They're next to each other. Also, so next to vocab here is linear pair. Linear pair are two angles that form a straight angle, a straight line. So like angle 1 and 2, not only are they adjacent to each other, they also form a linear pair, all right? Because they kind of form together. This angle 1 plus angle 2 is going to give me a straight angle, that straight line right there. They form a linear pair. Angle 3 and 4 are not linear pairs. They are adjacent, but they are not a linear pair because together they do not form a straight line. Complementary angles. Complementary angles are angles which together form 90 degrees. So let me try to show you something that looks like that. I'm going to try to approximate a 90-degree angle over here. Let's see how close I get it to it. There we go. And then I'm going to again try to approximate 90 degrees. I think that's pretty close. An approximation. I'm going to call that 90. I put this little symbol in there which indicates that's a 90-degree angle, and I need another line segment in here. I wish I picked a different color. There we go. There I go. Okay. All right. So right now, as it stands, this angle right here, I'm going to call it angle 5, and angle 6 Angle 5 and angle 6 are complementary. Complementary. Together they add up to be one 90-degree angle. Remember, that's that angle addition postulate thing we called part plus part equals whole. Angle 5 plus angle 6 will equal this big angle here, which is 90 degrees. So they are complementary. Supplementary. Pardon me, I'm going to cough. Still getting over my little thing. Supplementary angles. Actually, we have some supplementary angles that are already diagrammed here. Angles 1 and 2, not only are they a linear pair, but they are also supplementary to each other, right? That together they add up to be 180 degrees because that's the measure of a straight line, right? Remember the circle? Can I be fancy and do a circle? I'm not sure that I can. I thought I had a circle tool here somewhere, but now I'm not seeing my circle tool. I've got a protractor. I've got a ruler. Oh, is this a circle tool? That'd be pretty neat if it was. Oh no, this is a magnifier. Okay, looks like my technology has not accomplished quite what I wanted today. That's okay. You know what a circle looks like. Now I'm going to see if I can get rid of these. There we go, getting rid of that. Getting rid of that. Okay, so don't laugh at my circle. All right, there's my attempt at a circle, and there would be the center of my circle, and the circle has 360 degrees in it, and that's why a straight line has 180, right? So if a circle has 360 from here all the way over here is 360. Well, 360 divided by 2, a straight line to the circle, is 180. So that's why a straight line has 180 degrees. That's 180 is half of the 360 of the total circle. What else? Oh, and then of course that's why 90 degrees is what it is. This 90-degree angle. This is 1/4 of a circle. This is the angle measure of 1/4 of a circle. So that's why all these angle measures are important. 90 right here, 1/4 of a circle. 180, 1/2 of a circle, and 360, a whole complete circle. Vertical angles. Oh yes, this is important. Vertical angles. Again, another little vocab. Whenever two lines or line segments cross each other, they form vertical angles. Whatever this angle is here, it's got to be the same as this angle is here, and whatever this angle is over here, I got to give it 2 arc marks because I gave the other one 1 arc mark. These two are vertical angles, this one here and this one here. These are vertical to each other, which means they have the exact same measure. And this angle is vertical to that angle. I guess I could call this angle 7 and angle 8. I can call this angle 9 and angle 10. So angle 7 and 8 are vertical. They're the same. I could say that 7 is congruent to 8 because they're vertical. Vertical angles are always congruent to each other. And angle 9 is congruent to angle 10 because of vertical angles. So that's our vocab today. Getting rid of these diagrams. Well, that was silly of me. Do you see the silliness that I did? Maybe you don't see it yet. I have a warm-up here with no question. Oh, it looks like here. Apparently the warm-up is this over here. So just forget about this, just forget about this right now. You don't have to answer that. Everyone gets that point for free because it's a blank question. My warm-up is right here. The center of a pitching mound has coordinates 42.8 and 42.8. When a pitcher throws a ball from the center of the mound to home plate, what is the distance to throw to the nearest tenth? Let me pause this and make sure that there's no diagram that's needed for this question. Alright, well, through the magic of technology, I decided I needed to change what that warm-up was going to look like. So, remember how I said cross off that warm-up? Well, guess what? This is a digital product, right? I can change it right now. I can make a live change to it. And now we don't have a blank warm-up question over here to cross off, and I've given you a diagram on it. So when you fire this up, you'll see this diagram right here. So here it goes. The center of the pitching mound has coordinates 42.8, 42.8. So there's the pitcher's mound right there in the diagram, 42.8. What are the coordinates of home plate? So this is kind of a baseball question, really more than a math question. You have to know where home plate is here, right? So if you're looking at this, hopefully you realize home plate is right here. There's first base, there's second base, there's third base, home plate. All right. So home plate it's already given you right there. Home plate is at 0, 0. And you know, if you think about this is the coordinates of our graph. This is our y-axis here. This is our x-axis here. And home plate is right here because it's at the origin. It's at the start of where everything starts counting off. I don't know this much about baseball, but I'm guessing there's 90 feet between home plate and first base, which is why we have these coordinates here. And I'm guessing this very peculiar 42.8, which is not quite the half I would expect of 45. Half of 90 would be 45. Apparently home plate is a little bit off of the center of the baseball diamond. You baseball aficionados, you tell me what's what with this. Is this right? I gathered this from another resource, right? So the next question is going to ask us, and this is where the diagram comes in real handy, is the center of the pitching mound. Just making sure we're recording. Good. Center of the pitching mound has coordinates 42.8, 42.8. When the pitcher throws the ball from the center of the mound, here to home plate here, what is the distance of the throw to the nearest tenth? All right. So we're going to have to use the distance formula. We're going to have to use the distance formula to figure this out. Hopefully, you have memorized by now what the distance formula is. We've spent a couple days on it. But it looks like this. Now, remember, I've given you two choices. You can use the distance formula, or you can use Pythagorean theorem. I'll be showing both right here. Okay. So we have to take the difference of our y values. So x2 minus x1. Take the difference of those values and we square it. And then we add that to the difference of the y values, y2 minus y1 squared. All right. So what we have to do the distance formula here is we have two coordinates, right? We have the coordinates h is 0, 0, and we have the pitcher's mound. I'm going to call that P. Point P is 42.8. Oh shoot, 42.8, 42.8. Oh no! I just deleted everything. Can I undo the thing I just did? Okay. Woo! Okay. I just want an eraser. Just want to erase this little mistake. Didn't want to delete everything. Thanks, computer. All right. There's my 42.8. And I know this is distance learning, and I know it's all virtual and all, but feel free to grab yourself a sheet of paper and do these on paper rather than trying to plug away with them all on your calculator. And for those of you who don't have a calculator, by the way, in the Google Classroom, let me show that to you. In the Google Classroom, in the Google Classroom, I do have a resource. I don't have a resource? Well, let me create this resource. I'm going to reuse a post from one of my other classes. Where is it? Online graphing calculator. Okay, we're going to reuse this post. And since we're doing distance learning here, I'm going to post this into our geometry class. And there it is, online graphing calculator. So there is a post now in geometry on the Google Classroom called online graphing calculator. You have a few options. You have Desmos here. There is an Apple Store app that you can get, which has an emulator for a graphing calculator for the TI-84. Here's the link to the Apple one. And here's Wolfram Alpha. So all good resources for online calculators if you don't have one at home, but you still got your Chromebook. All right. So back to what we were about. Is this it? That's what we were about right there. All right. Here I go. So I know that y is going to equal. And yeah, some of you will say, Mister, this is a lot to keep rewriting. Yeah, it is. Sometimes it is. It's even hard for me because I got to write with a mouse. I don't like this. But it is what it is. So I'm going to do 42.8. This is an x value over here. Right? The first thing is my x, the next is my y. So 42.8 minus 0 squared plus, ooh, that's terrible, plus 42.8 minus 0 squared. There's my 42.8, my y value. Looks like an x, doesn't it? Oh, that was a mistake on my part. There we go. Now it doesn't look much better now. Don't make me laugh. Okay. That's okay. That's a funny looking Y, Mr. Salt. That's all right. We'll have to live with it. Okay, this is pretty easy math though. 42.8 minus 0? Oh, that's just 42.8. So really, I got a situation where it's 42.8 squared plus 42.8 squared. I don't need to rewrite all that. So let me just figure this out here. There's my graphing calculator. Clear all this. This is from the last lesson. 42.8 squared plus 42.8 squared gives me 3,663.68. Is it possible for me to remember that for long enough to write it down? 3,663.68. Let me see. Oh, I can write it now. So I know that y is going to equal the square root of 3,663.68. And fortunately, my calculator can handle that. That's no biggie. I'm going to press the square root button. Do you see that in blue right there? I press the second button first, then I press this button right here, which gave me that square root symbol like I want, and I can just type in 3,663.68, and when I press enter, I'll find out what the distance is between here and there. 60.52. 60, y is going to equal 60.5. Oh, it said to the nearest tenth. Nearest tenth, I'm done because it says 60.52. The nearest tenth is this 5 here. I looked at the hundredths place to see if it's 5 or greater or less than 5. It's less than 5, so I just keep 60.5. And then, of course, I want to do a little squiggly to say approximately. This is no longer an exact answer. I'm using an approximation. I'm rounding. So about 60.5 feet between here and there. All right. I promised you I would show this to you two different ways. This is, I gotta be honest with you, distance formula. That's the way they want to see it on like a geometry regents. But I told you that I'll show you a different way, which I find is easier for most of you. If this, what I just showed you, is all kind of scary, it's a lot. Don't worry about it. There is that easier way. And I'm just going to delete everything so we get rid of it. Here's the easier way. And why did I show you the hard way first? Because I think you can do it. You know, I think you can even do it the hard way if you try. But, you know, sometimes we're a little scared to give things tries for the first time. So we're left with other techniques. So, okay. Here I go. They told me this is at 42.8, comma 42.8, which means I know the distance between here and here is 42.8. And I drew in a little triangle here, and notice that this is a right triangle. This is a 90-degree right triangle. And what do I know about right triangles? Well, I know something. I know about right triangles that A squared plus B squared is going to equal C squared. Now, C is this right here. C is the hypotenuse, the long side of the right triangle. And I know that A and B are going to be these two sides. Well, I know this side's going to be 42.8 because of this 42.8 here. I know that it's got to be 42.8 this way too. 42.8 the other way because that's the coordinate point, right? It starts at 0, 0, 42.8, going to the right, 42.8 going up. That's what this 42.8 means go to the right, 42.8 feet. This means go up 42.8 feet. So I already know right off the bat that, oh, sorry, this is going to ding. Got a grandfather clock behind me. 42.8 squared plus 42.8 squared is going to equal the same as c squared. C squared right there. All right. Again, did you notice that's pretty similar to what we did on the distance formula? Huh? Did you notice that? Were you following this, right? Actually, I wish I hadn't cleared all that, because then that could have showed me that we're kind of doing the same idea. 42.8 squared plus 42.8 squared is 3,663.68. Well, wait a minute. That's what we had before inside the square root of the hypotenuse, right? So now I know that 3,663, that's a terrible 3, that's even worse 3, but alright, that's the best I can do right now. 8 equals c squared. Alright, but I don't want to know what c squared is per se. I want to know what c is. I want to know the distance between here and here. So how am I going to get this just to be c by itself? Well, c squared, remember, is really the same thing as c times c. Whatever c is times whatever c is, that's what c squared means. So what I can do to get rid of this c squared nonsense is I can do a square root, right? Square root does the opposite, right? A square root of c squared, this cancels this to be just c. So if I put a square root over here, it cancels this squared it kind of thing, which gives me just c by itself. But remember, what I do on one side of an equation, I got to do on the other side. So there we are. So I got to square root this big number here. So remember we did that on the calculator when we used the distance formula? Square root of 3663.68. And we find, magically, it's the same gosh darn number we had last time, 60.5. 60.5, and I'm rounding the nearest tenth because that's what the question asked me to do. Round to the nearest tenth. So I'm going to give a little squiggly, saying approximately. There it is, two different ways of the distance formula. Okay? I think that this way, Pythagorean theorem method, is the easier way to do it. The problem, the reason why I don't, the preferred way is the distance formula, is because what if they don't give you a graph? And what if the numbers are really funky, right? What if it's like 1,000, the x value is 1,052, and the y value is 2,087? You're not going to be able to graph that, right? You're not going to be able to go on graph paper and figure out what the right triangle is going to look like because it's too big of a shape to graph on paper, which is where the distance formula comes in because you're just popping coordinate points in. So distance formula is handy in all sorts of situations where the Pythagorean theorem has a little bit of a practical limitation of you need to be able to graph it and look at it and to make it easier. All right, but we'll move on. We've actually already done some of this, bisecting an angle. So an angle bisector is a ray or any other line segment or other figure that divides an angle into two adjacent angles. So here CD is the bisector. It divides this angle ACB. It divides it in half, forming two congruent angles. This angle here is going to be congruent to that angle here because that's the bisector. That's what it means to bisect. It means to cut exactly in half. And so now if it cuts exactly by half, I know that this angle has got to be the same as this angle. That's what this expression here says. It says the measure of angle ACD, angle ACD, is going to be equal to the measure of angle BCD, equal to the measure of BCD. These two angles now are the same because CD is the bisector of the big angle. You got that? All right. Here's one way to visualize an angle bisector. You can literally, if you have the angle on paper, we did this once on class, we actually folded the paper in half so that the two sides of the angle overlapped each other, right? If they fold the paper so the two sides overlap each other, that will also form the angle bisector. And already in class, we've done the construction on how to form an angle bisector, but this is kind of a reminder of how you do it. You use your circle tool, known as a compass, and then you create an arc, right? What you're doing is you're trying to create two congruent segments between CB is going to be congruent to CA. You're then going to use that same compass measurement in two places, here and there. You can do one arc, start centered on A, and you want that arc that looks like this. Then you're going to move your compass over to center it on B, and you're going to make another arc that looks like this. And where those two arcs overlap, that is going to be your angle bisector. You draw a straight line from D all the way to C. That's your angle bisector, dividing an angle in half. And of course, there's some math involved in some of this, right? This is how geometry is going to start connecting to the algebra. Here's the situation. We were told that ray FH bisects angle EFG. All right, ray FH bisects the angle EFG. Given that the measure of angle EFG is 120 degrees, so EFG is 120 degrees, this whole thing is 120. What is the measure of angle EFH? EFH right here. And measure of angle HFG. HFG. Well, if this is the angle, if ray FH bisects this big angle, which is 120, that means it cuts it in half. 120 divided by 2 is 60, which means each of these are 60 degrees. Angle EFH is 60 degrees. Angle HFG is 60 degrees. Right? It's fair enough. Again, we already talked about adjacent angles, but adjacent angles are angles that are next to each other. Angle 1 here and angle 2 here are adjacent angles. They share a side, right? They share a common side, so they are adjacent angles. And then sometimes 3 and 4 are also adjacent, but they're not only just adjacent, they also form a linear pair. They're on the same line. Angle 3 plus angle 4 will definitely equal 180 degrees, and I know that because they're a linear pair. Again, these are just notes, just reminders about stuff you'll need to go forward with the exercises. Identifying angle pairs. Tell whether the angles are only adjacent and form a linear pair, or not adjacent. So let's see. Angles 1 and 2. So looking at angles 1 and 2, I can see they're adjacent. They share this common side. So they are not a linear pair, but they do share a common side. They also share a common vertex, which is B. They're only adjacent. Angle 2 and angle 4. So there's angle 2. There's angle 4. They share this BC piece, but they don't have a common vertex. So they're not adjacent angles. So 2 and 4 are not adjacent. They don't have the same vertex. They do share a common side, though, just not the same vertex. So not adjacent, not adjacent. And angles 1 and 3. Angles 1 and 3 are clearly adjacent. They share a common vertex. They share this side right here. And the thing is that 1 and 3 are not only adjacent, but they also form a linear pair. Together, angle 1 plus angle 3 is going to equal 180. They're on the same line. All right? Feel good about that, hopefully? Tell whether the angles are only adjacent, and form a linear pair, or not adjacent. So you tell me, angles 5 and angle 6. There's angle 5. There's angle 6. You tell me whether these are adjacent, not adjacent, or adjacent and forming a linear pair. I recommend pausing right now, giving this a shot. Again, it's like piano, it's like basketball, it's like speaking another language. Sometimes you got to do things to learn things. You can't just watch someone play piano and learn how to play. You can't just watch people playing basketball and know how to play. You got to do. You got to do sometimes. So I'm asking you to pause and try to do. All right? These are skills. All right. Hopefully you've paused, right? Keeping yourself honest. You paused and you gave this a shot. Good for you. Good for you for giving this a shot. Angles 5 and 6. And here's angle 5. There's angle 6. So they share a common side. That's good. And they share a common vertex. Dang, these things are adjacent. And do they form a linear pair? Oh, heck yeah. They're on this line QT right here. All right? So if you were to write this, you'd say adjacent and form a linear pair. All right? Tell whether the angles are only adjacent, and form a linear pair, or not adjacent. Angle 7 and angle SPU. There's angle 7 there. SPU. Okay, SPU is this big angle right here. So, let's see. Hopefully you paused this and you gave this a shot. All right. All right, this is one of those special cases. Maybe you said these are adjacent. Maybe you said angle 7 here. Maybe you thought, gotta remember that. Maybe you thought to yourself, angle 7 is going to be a linear pair with SPU because they do share a common side and they share a common vertex. This is one of those special cases where they're not exactly adjacent because they overlap. They overlap with each other. So that's a problem here. So in this one, I would just say no. Just write down, nope. They overlap. So they are not adjacent. Tell whether these are angles. Angle 7 and 8. There's angle 7. There's angle 8. Are they adjacent? Are they a linear pair? You're pausing. You're taking a guess. Okay, you paused. You took your guess. Hopefully you said no, right? They share a common vertex, but they don't have a common side. So they are not adjacent. And they're not a linear pair either. They are on the same line, but to be a linear pair, they'd have to add up to 180 degrees, and we got a major bite with angle P here, or RPS, that is out of this. So this is not adjacent. Not adjacent. Okay? All right, complementary and supplementary angles. Complementary angles, as I said before, are two angles that add together to get a sum of 90. When you think of sum, you want to think of addition. So two angles that add up to 90 are complementary. Two angles that add up to 180 are supplementary. And you just got to have these definitions memorized. They're just going to expect on the geometry regents that you just know this kind of stuff. Now, most of you aren't taking the geometry regents, but I'm, trying to get you prepared with the geometry curriculum that we're given here. So let me experiment. Let's see what this is about. Hello, Mr. Calculator, friendly math machine. Help me out. What is 37 plus 53? 37 plus 53. Oh, that's 90. So angle B and angle A are complementary. Together, they add up to be 90 degrees. All right? Angle B and angle A are complementary. What about maybe angle A and angle C here? Let me add these up. 53 plus 127, and that's 180. And that's 180 right there. So angle A and angle C are supplementary angles. They add up to be 180. So, and this is just notes here. If they gave you an angle and they said find the complement of angle M, well, you'd have to say, well, I know that the complement of angle M would have to add to this to be 90, right? Whatever the complement is, this angle M plus the complement would equal 90. Therefore, if I take 90 and I subtract 26.8, I'll get 63.2. Bringing that calculator back, right? And 63.2 plus 26.8 will give me 90 again, right? Does that make sense? Oh, wait, what did I do? Haha, I don't know what. I pushed the wrong button. There I am, being silly again. Plus 26.8. There it is. 63.2 plus 26.8 equals 90. So you see how they figured that out? They said, well, 90 minus 26.8 will give me the number that if I was to add to 26.8 will give me 90. Sorry about that. Okay. The supplement of n. So the supplement. I know the supplement of n will add with n to give me 180. So, but they're not giving me exactly, they're not going to give me exactly the number. Supplement of n is angle n. They're going to tell me it's 2y plus 20. Well, all right. So I can kind of figure this out. I'm going to leave it in some algebraic form. That the supplement of n is going to be 180 minus whatever n is. So I'm going to take 180 minus 2y minus 20. Right? I'm going to distribute this subtraction out here. What I'm going to essentially do to distribute this, I'm going to pretend there's a 1 out in front of here. And I'm going to distribute that 1 to the 2y. I'm going to distribute that negative 1 out to the 20, which gives me negative 2y, negative 20. And then when I add all this together, 180 minus 20 is 160. So I have the supplement of angle N is going to equal 160 minus 2y. 160 minus 2y. All right, fair enough. Let me get rid of all that. So now you're going to be expected to find the measure of these angles. Find the supplement of angle F. Find the supplement of angle F. Pause here, give this a shot. You can do this. All right, hopefully you unpaused. And here we go. Well, I know that the supplement of angle F is going to be, when I add it to 180, will give me, when I add the other number, will give me 180, right? So what I got to do here, I got to take 180, and I got to subtract 116.5, and whatever that is, that'll be the supplement of angle F. That'll be the supplement of angle F. So 180 minus 116.5 gives me 63.5. All right, 63.5. 63.5. Okay. And let me test this theory. Am I right? 163.5 plus 116.5 should give me the 180, right? If you don't trust yourself, you can always confirm. So that 63.5 is most certainly the supplement of angle F. 63.5 is what you'll write in there. Fair enough. We'll move on. Find the measure of each of the following. The complement of angle E. Find the complement of angle E. Pause and give this a shot. You can do this. All right, you've unpaused because you've given it a shot, and hopefully you're about to get the same answer I'm about to get. Hopefully we're going to be in agreement. So I know that this plus a number, which is the complement, should give me 90, right? So to figure out what that number is going to be, I'm going to take, I know that 90 minus, this is supposed to be a parentheses there, 7x minus 12 is going to equal the complement of E, right? Because the complement means adds together to be 90. So I got to do that distribution trick again, right? I got to pretend there's a negative 1 out in front of here and distribute the negative 1 to each piece inside that parentheses. Each piece inside that parentheses. So negative 1 times 7x is going to be negative 7x. Negative 1 times negative 12 is going to be positive 12. And so I have 90 now plus negative 7x plus 12. What's 90 plus 12? Well, that's 102. 102. So now I know that the complement of angle E has to be negative 7x plus 102. All right. Good. We'll move on. Let's see, and it gets a little bit more complex, right? Using complements and supplements to solve problems. So let's say that there's an angle. The measure of angle A is an unknown number of degrees. We'll call it x degrees. Then B, its complement, is going to be 90 minus x, right? Whatever, if it's B is its complement, then whatever 90 minus x is, that's what the measure of B is. So we can start to substitute these expressions inside equations to figure things out. If we know the measure of angle A is the same as 2 times the measure of angle B minus 3, all right, A is x. Remember we said A is going to be x. We said B is going to be the same as 90 minus x, so 2 times the measure of angle B, 2 times 90 minus x minus 3. We're going to then distribute this 2 to the 90 and the negative x, right? So 2 times 90 is 180. 2 times negative x is negative 2x minus 3. I can combine these like terms here. 180 minus 3 is 177. So I'm left with the expression that x equals 177 minus 2x. But now I can get my like terms of my x's together. So I can add 2x on both sides, which cancels it over here, which leaves me with 3x equals 177. Divide by 3 on both sides, and I find that x is 59. If x is 59, I can find out what measure, that's what A is. Measure of angle A is 59 now. And to find that B, I do 90 minus 59. 90 minus 59, that's 31. The measure of angle B is 31. So I provide you these examples as notes so that you can kind of follow along, see what's happening, and kind of reproduce what the questions are going to ask you. An angle's measure is 12 degrees more than 1/2 the measure of its supplement. Find the measure of the angle. You can choose whether to pause here or not and give these a shot. I know these are tough for you, tough for a lot of people. So, have no fear. An angle's measure, all right? An angle's measure, they're being sneaky about it. They're not going to tell me what it is. So I'm going to need to call it X, or I can call it Z, or I can call it whatever, Q, R, S, whatever you want to call it. We tend to stick with X. It's just, convenient tradition. An angle's measure is 12 more than. So somehow it's going to be 12 more than 1/2 the measure of its supplement. Okay, 1/2 the measure of its supplement. So that 12 more than is 12 more than half the measure of its supplement. So I need that plus 12 over here. Now its supplement. Supplement should equal together be 180. Again, I have to have that. I just have to know that. 1/2 the measure of its supplement. So I have to have a fraction 1/2. 1/2 its measure of its supplement. I can kind of express what its supplement would be. And I can say it's 180 minus x. Right? It's 1/2. So let me see if I've got this right. An angle's measure is, so is means equals. An angle's measure is 12 degrees more than, there's my 12 degrees more, then 1/2 the measure, the measure of its supplement. Its supplement is 180 minus itself. So I would then need to play around with distributing this 1/2. Well, I got to distribute that over here. Then I got to distribute that over here. So that gives me, let's see, 180 times 1/2, that's 90. I just know that. If you need to use your calculator to figure that out, that's fine. 1/2 times 80, 1/2 times 180 is 90. 1/2 times negative x, it's going to be negative 1/2 x plus 12. Plus 12. It's going to equal x. I'm going to combine my 90 and my 12 now. 90 plus 12 is 102. I'm going to add 1/2 x over here. 1/2 x. Why? Because this gets this whole piece here to cancel. But if I do it on one side of the equation, I got to do it on the other. 1/2 x, which means I have basically 1 and 1/2 x over here now. 1 and 1/2 x equals 102. And then I'm going to divide by 1 1/2. I'm going to divide by 1.5 on both sides of my equations. I want to break out the calculator at this point. 102 divided by 1.5. 102 divided by 1.5. 68. X is 68, right? X is going to be equal, because, right, this cancels here. X is going to be equal whatever 102 divided by 1.5 is. And my calculator told me that 102 divided by 1.5 is 68. 68 equals X. I know those are tough. You can handle that. You just need to get better at it by practice. And again, you get better at piano by practicing. You get better at basketball by practicing. You get better at a lot of skills by practicing, and math is no exception. So when you might be asking yourself, well, where in the heck am I ever going to use this? Well, maybe you will, maybe you won't. But certainly there are applications to this. And one application that uses angle pairs and the relationship between angles is in fiber optics. Scientists use the properties of angle pairs to design fiber optic cables. Have you ever seen a fiber optic cable? Gosh, it makes me want to show you a video of fiber optic cables. You know what? I do want to show you a video of fiber optic cables, but I don't want to show it to you in this video. Rather, what I'll do is I'll plug one of these videos into your lesson, and you can watch it on your own if you so choose, rather than take up the time here. So fiber optic cable is a strand of glass as thin as a human hair, and it actually transmits light by bouncing like light off the inner walls of this thing. And this transmits so much faster than electricity. Maybe if you've heard of fiber optic internet. Fiber optic internet speeds are amazing because this is so much faster than wire transmission. And this is kind of like the inside of a fiber optic cable, right? Light is bouncing back and forth off the inside, and notice that there are some angle pairs being formed when this occurs. Light passing through the fiber optic cable reflects off the walls in such a way that angle 1 is going to be congruent to angle 2, and that angle 1 is going to be complementary to angle 3, right? These two are going to add up to be 90 degrees. And angle 2 and 4 are also complementary. They're going to add up to 90 degrees, which means if angle 1 is 38 degrees, then we can find the measure of everything else, right? If angle 1 is 38, then I know it's complementary with angle 4. So I know 1 and 3 together are going to add up to be 90. They told me that they're complementary. So if angle 1 is 38, 90 minus 38 is 52. Angle 3 has to be 52, because that 52 is the only thing that'll add to 38 to give me 90. I'm told that measure of angle 1 is congruent to measure of angle 2, which means if this is 38 degrees, then angle 2 has to be 38 degrees as well, because they told me that these two things are congruent. It's what this little symbol here is. Measure of angle 1 is congruent to angle 2. All right, and right, we can then, and then I know if angle 2 is 38 degrees then, and I know that these two are complementary, I can find measure of angle 4 is going to be, what did I say, 58? 52. 52. So that's 52, that's 52, these both are 38. I figured all that out with just a few assumptions about the relationships, and that one angle is 38. And this kind of gives it more in depth. We're going to move over here. Suppose the measure of angle 3 is, suppose this measure is 27.6 degrees. Find the measure of angle 1. So here's the things you can assume. Oops, nope, not all that. You know that angle 1 is congruent to angle 2. You know that angle 1 plus angle 3 equals 90. And you know that angle 2 plus angle 4 is 90. Alright, with that information there, find the measure of angle 1 if this one here is 27.6. Pause and give this a shot. Alright, hopefully you gave this a shot. So, I'm going to focus on this right here. Angle 1 and angle 3 together are going to give me 90. I'm told that they are complementary. Complementary. Which means this measure of angle 1 here is going to be 90 minus whatever this is. So, I'm going to go to my calculator. 27.6. I got to remember that number. 90 minus 27.6. 62.4. Alright. So 90 minus 27.6 is the same as 62.4. So I now know that measure of angle 1 has to be 62.4. Sorry, that little clock will go every 50 minutes. And that's, I solved that one. Alright, I'm going to let you go and handle this one on your own. And this one on your own, right? I think we're going to let you give this a shot, independent. I'm not going to go over these. I showed you the example. I showed you the example here. I did this one right here. I want you to do the rest of these right here, these next two. vertical angles. So remember, vertical angles are congruent to each other. They're non-adjacent, and they're formed by two intersecting lines. So, oop, I want to get rid of all that. Getting rid of it. Okay. This angle here, call that angle 1. This angle here, call that angle 2. Angle 1 is going to be congruent. Angle 2, I know this just by looking at this is one of the beautiful things about vertical angles, is it's something you can know just by looking at the diagram. I don't have to know anything else. I know that two straight geometric figures have crossed right here, and I know that this angle and this angle are vertical because of just the way the diagram is drawn, that they are vertical, which means they have to be congruent. And this can be useful information in all sorts of different ways. I can also know that this right here, I got to give it 2 arc marks because I gave my other 2 pairs 1 arc mark, that 3 over here, I'm just giving them random numbers, 3 has got to be congruent to 4, right? Because this is the same thing, same idea, vertical angles. Angle 3 and angle 4 are vertical, therefore they have to be congruent. All right, feeling good about that? I'm going to give you a diagram. Name another pair of vertical angles. Do they appear to have the same measure? So over here, when I say another pair, I already in this notes I said that the measure of EDF is the same as the measure of GDH. So this and this are congruent. I'm asking for another pair. So you would say angle EDG is congruent to angle FDH, right? EDG is congruent because vertical, because they are vertical angles. All right. We are at the Check for Understanding. We are at the Check for Understanding. You are on your own for these, as always. Complete this. Complete the reflection. I'm thinking this is good till Wednesday. This is good till Wednesday. There's some extensions here. You don't have to do extensions. They are bonus points. They will be bonus points. You don't have to do them. And I think we are good for this. So click submit. I hope you're liking these videos. I hope these work for you. Distance learning, extreme, we've always had the Google Classroom, but usually the instruction happens mostly in the classroom. But now for those of you who are having a little struggling with that attendance piece in the classroom, maybe this is for you. We're kind of forced to do a little distance learning here. So hope you're all safe. Hope you're all healthy. Well, until next time, we'll see you. Let's get our learn on.